Okay, to start off Unit 4 for Maths Methods, we go back to our derivatives again, but in this time we're looking at the second derivative. Now, a lot of our work around the second derivative is more about identifying inflection points on cubics, but to start with, we're just going to look at what that second derivative means. So basically, you're finding the derivative, and then you're finding the derivative of your answer. Basically, what's in the name, the second derivative. Do the first derivative, then do it again. Two different ways that you might see notation for that, other than asking you to find the second derivative. You might see f double dash x, so you would have been used to seeing f dash x for the derivative. So for the second derivative, we have two dashes there. The other way that you might see it is d squared y over dx squared. So they're your two different forms of notation that you might see. And I've just got two examples I want to have a look at. So we've got the first one is a cos function. So our y equals 3 cos of 4x plus 1. Now when we're doing the derivative for cos, we know that it's going to go to negative sign. This bracket part stays the same. And we're bringing out the front whatever the derivative of this part is. So the derivative of 4x plus 1 is just 4. So we're bringing that out the front and multiplying that by the 3. So we'll have negative 3 times 4 is negative 12 sine of 4x plus 1. But we're not finished because we have to do the second derivative. So now we're going to do that again to get our second derivative. So our sine is obviously going to go to cos. We're going to keep that negative there. We've got the 12. We need to multiply it by the 4. And the bracket part stays the same. Then we'll just simplify that part here to negative 48 cos of 4x plus 1. So that's our second derivative of our 3 cos 4x plus 1. So obviously when you're doing your second derivatives, you do need to know your derivative rules well. So you're going to need to go and revise those derivatives from Unit 3. You can't just throw that away and forget about your Unit 3 and Unit 2 derivative rules because you're going to use them again in Unit 4. The next one we've got here is our y equals 2x e to the x. So when we see that, we know that we're going to use the product rule to do the derivative there. So our u, v, we want to, when we're doing that, also say that we're using the product rule, needing to get into that habit for external exams because they're going to be marking for that. So we've got u is equal to 2x, v is equal to e to the x, our u dash is going to be 2, and our v dash is going to be e to the x because the derivative of e to the x is e to the x. So our derivative there is going to be u dash v plus v dash u. And so we'll pop them back in. So we've got 2 lots of e to the x plus e to the x times 2x. Then we can simplify that to 2e to the x plus 2x e to the x. Now, we then have to do that again, the derivative. Luckily, we do have a little shortcut we can use. So we know that 2e to the x, the derivative of that is just going to be 2e to the x. Then we already have done 2x e to the x, so that's what we started with. So we can put that answer straight back in. 2e to the x plus 2x e to the x. That saves us doing that whole derivative section again. Then we can simplify that to 4e to the x plus 2x e to the x. Now this question actually had find when the second derivative is equal to 0. So we need to set that as equal to 0. 0 equals. Then we can take that 2x e to the x over to the other side, make it a negative, and we get 4e to the x. Now we can see we've got an e to the x on both sides, so we can divide by that. That leaves us with negative 2x is equal to 4. Then we can divide by negative 2, and we get x is equal to negative 2.